Hello students, welcome to Exam Companion. Before starting, I would request you all to please subscribe to my channel and press the bell icon so that you never miss an update. Today, we'll study Chapter 3 of NCERT Geography textbook for students of Class 7th. The name of the chapter is Our Changing Earth. Now students, in Chapter 2, we studied about lithosphere, which is the outermost shell of an earth. And we also studied that lithosphere consists of the crust and upper part of mantle. So let's see what are lithospheric plates. Lithospheric plates are the regions of Earth's crust that are broken or fractured into plates. The Earth's crust is broken into plates and these plates are called lithospheric plates. These plates can be large or small in size and there are total 20 lithospheric plates, out of which 13 are large. Now students, do not let the word plate confuse you. These are called lithospheric plates, but they are not flat like plates or slabs. They are irregularly shaped. Now you must remember that deep inside Earth's surface, rocks are in molten form, magma. So because of this magma, lithospheric plates move slowly. The movement of these plates causes changes on the surface of Earth. Now students, if you keep a notebook on the table, can it move on its own? No, right? Similarly, these plates don't move on their own. They require some force. So on the basis of the force that caused these movements, we have divided Earth's movement into endogenic and exogenic. Endo means inside and exo means outside. Genic means origin. So endogenic forces are the forces that act inside the surface of Earth or interior of the Earth. Now, endogenic forces may be either sudden in nature, like natural calamities, volcano, landslides, earthquakes, or they may be diastrophic in nature. Diastrophic forces are those forces that are caused in response to mountain mass, ocean mass, building mass, and so on. So, exogenic forces are the ones that act on the surface of Earth, and these are mainly erosional and depositional forces. These forces can be caused by river, wind, glaciers, and sea waves. We will study all four of these in detail in the later part of the chapter. Now, let's study about volcanoes. A volcano is a vent or opening in the Earth's crust through which molten magma erupts suddenly. Now remembering this diagram is very easy. Let's see how you can remember the name of all these. So you know that molten rocks are called magma. So there is a magma chamber. You are already familiar with the crust and mantle. So remembering these two names is not an issue. Now, according to the definition of volcano, it's an opening or vent through which molten material erupts suddenly. So there must be a vent in the diagram. So here we have the vent. Now when the magma breaks through or erupts from the Earth's surface, it's called lava. Again, when magma erupts and comes on the surface of Earth, then it's called lava. Until it's inside the surface of Earth, it's magma. It's also obvious that when hot magma erupts from the surface or from volcano, there will be gases and ashes, right? And lastly, there is crater. So to erupt from the surface of Earth, there must be a hole or depression in the surface of Earth, right? So a crater is a depression or hole in the surface of Earth caused by a volcano. So this is how we have crust, mantle, magma chamber, vent, lava, gases and ashes, and crater. Students, it's a very simple diagram and you can easily link the following names. Now, let's move forward. When lithospheric plates move, the surface of Earth vibrates. These vibrations can travel all around the Earth. And these vibrations are called earthquake. The place in the crust where movement starts is called focus. So students, focus is a point or is a place in the surface of Earth. It's inside the surface of Earth. It's actually present in the crust. The place on the surface of Earth above focus is called epicenter. So, epicenter is a point or is a place which is on the surface of Earth and which is directly above focus. As you can see here in the diagram as well, epicenter is directly above focus. Focus is the point which is below, epicenter is the point which is above. Vibrations travel outside from epicenter as waves. So say if this point is epicenter, then vibrations will travel in the direction of the arrow. The greatest damage caused by an earthquake is at the epicenter. So if this is the surface of the earth, then the greatest damage will be at the point where I am pointing currently. The strength of the earthquake decreases as we move away from the epicenter. So if this point is the epicenter, then as we move towards this arrow, in the direction of this arrow, the direction of the strength of earthquake will decrease. That is why you can see that the innermost circle is dark blue, the middle circle is moderate, and the outermost circle is light blue. So the strength decreases as we move in the direction of the arrow. Now, we just discussed that vibrations caused by an earthquake travel outside and travel around the surface of Earth. These vibrations travel as waves, and there are majorly three types of earthquake waves. The first type of waves are P waves or primary waves. These are also called longitudinal waves. They are the fastest of the three waves and they can move through both solids and fluids. The next type of waves are called S waves or secondary waves. They are also called transverse waves. They are slower than P waves, but they cannot move through liquid medium. They can only move through solid medium. The third type of waves are L waves, also called surface waves. L here stands for love. These waves were named after a British mathematician and they have lower frequency than P waves and S waves. So how do we get to know when an earthquake has hit? The earth shakes, things start to fall and so on, right? But is that it? There must be a device or machine to detect earthquakes, right? That machine is seismograph. A seismograph is an instrument used to detect and record earthquakes. The goal of a seismograph is to record the motion of ground during an earthquake. So, seismograph is the machine that is used to detect and record earthquakes. Remember this. Now, how do you measure length? Say, if you have to draw a 5 centimeter line, then how do you do that? You use a scale, right? You use a scale to measure 5 centimeters. Similarly, to measure the intensity of the earthquake, we need a scale. That scale is Richter scale. It is a scale of numbers used to tell the power of an earthquake. So Richter scale is a scale, it is not a device, whereas seismograph is a device or an instrument. An earthquake of 2.0 or less is hardly felt. So if an earthquake shows 2 on Richter scale, it is a minor earthquake. It is hardly felt. An earthquake between 2 and 5 on Richter scale causes some damage. Things start to fall and so on, but buildings do not break. An earthquake above 5 is considered very strong. And finally, an earthquake of magnitude greater than 7 is classified as major earthquake, and it destroys a lot of buildings and monuments. An earthquake of magnitude 6.9 hit Bhuj town in Gujarat in 2001, and a lot of people died because of that earthquake. Also remember that the most powerful earthquake ever recorded was of magnitude 9.5 that hit Chile in 1960. You don't have to memorize the last point because it's not given in NCERT. I've just told you for the knowledge. Students, one thing that you must remember is that earthquakes are caused by sudden forces, which are a type of endogenic forces. This is a question in the back exercise of your NCERT textbook. Earthquakes are caused by sudden forces, which are type of endogenic forces. Also, when an earthquake hits, you should find a safe spot under a table or a bench and stay away from chimneys and windows because glasses can get shattered and hurt you. Now, we will study about weathering and erosion. Weathering is breaking up of rocks on the surface of Earth. A big rock breaks into many small rocks, whereas erosion is wearing away and transportation of landscape by natural forces such as wind, water, etc. Due to erosion, small particles of dust and small stones get separated from, say, for example, a rock, and then they get transported by wind, water, air, or glaciers to some other place. So, what is the difference between weathering and erosion? Weathering does not involve movement of dust particles or sediments, whereas in erosion, first they get separated from a rock or surface and then they are transported by wind, water, air, or glaciers. Now students, here I have depicted the erosion process. Say for example, these are particles of rock or these are particles of sand. All these are particles. So when a wind blows, then it removes these particles and carries these particles with itself. So here we can see that these two particles got separated from the surface and now here they can start getting deposited. So now there are two particles and sometime there will be 10,000 lakhs. So erosion, that is breaking away and transportation, and deposition, that is collection. I hope this is clear. Now students, we saw this flow chart in the beginning and saw that endogenic forces are erosional and depositional forces. As you can see that endogenic, and there is only one type, erosional and depositional. So for example, we studied that due to wind, the particles of rock got eroded and deposited. Instead of wind, there can be river, glaciers, or sea waves as well. So these can be carried out by four agents: river, wind, glaciers, and sea waves. Now we will see that how each of them affects the landforms. Work of a river. Here we will study about waterfalls, ox-bow lakes, and delta. Let's see each of them one by one. Waterfall. When a river tumbles or falls upon hard rocks, it forms a waterfall. Now, when a river falls, it erodes soft rocks more than hard rocks because soft rocks wear away very easily. Hence, you see this kind of a pattern because soft rocks erode more as compared to hard rocks. That is why we are seeing this pattern, whereas soft rocks due to erosion gets a curve, whereas the hard rocks are pretty much in rectangular shape, right? Now, meanders and ox-bow lakes. Meanders are horseshoe-like curves. Now, this is an actual photo of a meander taken from a helicopter or a satellite. So you can see that there are these curves which are in the shape of horseshoe. So meanders are horseshoe shaped like curves. When a river enters plain, it twists and turns and forms large bends or curves called meanders, which are in the shape of horseshoe. Also, a river has more force on the outside of the bend, which is here. A river has more force on the outside of the bend where it has most energy, and on the inside it has less force. So erosion happen on the outside, that is breaking away of particles happen on the outside and these particles get deposited on the inside of the bend, and this process keeps on happening. So what happens? Let's repeat. On this bend, on the outside bend, erosion will happen. Particles will break away. Water will carry these particles, and when an inside bend comes, for example here, these particles will get deposited. So over time, the ends of these horseshoe come closer and closer, and eventually the loop is cut off from the main channel to form an ox-bow lake. So what happens is that over time these bends keep on coming closer and closer, and what happens is when these bends join or when these bends become very narrow, the part of the river cuts off and form ox-bow lake, which is shown here. This is an ox-bow lake. I hope I am clear. Now we'll study about floodplains and levees. So what happens is when a river overflows, it deposits layers of fine soil and sediments on the river banks, right? So this layer of fine soil and sediments leads to the formation of flat fertile plains called floodplains. Also, a floodplain is an area around a river that is covered in times of flood. So this is a simpler definition. Now, what are levees? So as I just told you that during the time of an overflow, the area or the banks of the river are covered with water, and water deposits sand and sediments, right? So due to the deposition of sands and sediments, the banks get raised, they get elevated 1 inch, 2 inch, or maybe sometimes 4 or 5 inch. So a buildup of soil and sediments on the banks of a river can raise the river bank, and these raised river banks are called levees. Now, what is a delta? As the river approaches the sea, the speed of flowing water decreases and the river begins to break into a number of small streams called distributaries. So what happens when the river approaches the sea? Its speed decreases, and from one river many branches arise. So it's like a tree. So these branches or these small streams are called distributaries. So what happens next is river keeps on depositing material, sand and sediments, and sea keeps on removing it. But a time comes when the river starts depositing more sediments than the sea can remove, and this leads to the formation of delta. Deltas are found at the mouth of large rivers, for example the river Mississippi, and they are formed when river deposits its material faster than the sea can remove. Next, we will study about work of sea waves. So say there is a rock in the river and the waves of the sea keep applying pressure on the rock. So what happens? Cracks develop, right? With time, these cracks become large and wider, and thus hollow-like caves are formed on the rocks. Hence, sea caves are formed. Now, the waves of the sea keep applying pressure on the cave. So eventually, only the roof of the cave remains, thus forming sea arcs, a kind of hole in the rock. Now, still, the sea waves keep on applying pressure on the sea arc. So, what happens? Even the ceiling of the sea arc gets broken. So, only the walls remain. Hence, the structure formed are called sea stacks. Now, sea cliff is a mass of rock that rises very high and is almost vertical. These are generally found in coastal areas. Also, sea waves deposit sediments along the shores, and hence beaches are formed. So how are beaches formed? When sea waves deposit sediments along the shores. Next, we will study about work of ice. So glaciers. What are glaciers? Glaciers are nothing but rivers of ice, or we can say glaciers are frozen rivers. And we saw like river carry along sand and stones, and they eventually build up to form deltas. Similarly, glaciers also transport sand and stones that build up to form moraines. So moraines are nothing but deposits left behind by a moving glacier. There are total 4 types of moraines. You need not remember their types. This is just for the knowledge purpose. What are moraines? The deposits left behind by a moving glacier. I hope I am clear. Now coming to the last topic of the chapter, we will study about work of wind on the landforms. So what are mushroom rocks? As the name suggests, these are rocks that look like mushrooms. They are generally found in deserts. Now students, a question may arise. How are these types of rocks formed? The answer is erosion. Winds erode the lower part more than the upper part, and hence lower part becomes thinner and upper part remains wide, thus forming rocks that look like mushroom. As you can see, these two are the pics of mushroom rocks. Next, we have sand dunes and loess. When wind blows, it carries particles of sand along with it, and when it stops blowing, the sand falls and gets deposited in a low hill-like structure. So what happens, like we saw in erosion, similarly, what happens is winds carry particles of sand, and when the wind stops blowing, the particles drop, and so one particle, two particle, and millions of particles drop, and they get deposited in a hill-like structure. These hill-like structures are called sand dunes, and they are generally found in India and the United States of America. Now, what is a loess? So when the sand grains are light, or when the sand grains are very fine, when they are small, so wind can carry it over long distances, right? So when wind carries light or small sand grains over long distances, and such sand is deposited in large areas, it's called loess, and these are majorly found in China. So students, with that we have completed chapter 3 of our geography textbook for class 7th. Please like and share this video and subscribe to my channel. I will see you in the next video. Until then, take care.